In this video, we're going to be looking at the graph of the function, or the graph of its derivative, or the graph of its double derivative, and we have to answer characteristics about the original function f. Okay, so let's look at the objective. The objective is state characteristics about the graph if given the function. In other words, I'm giving you f, state characteristics about f. Number two, state characteristics about the graph of f if given the picture of the derivative. And the third objective is state the characteristics about the graph of f if the graph of the second derivative is given. So basically, you're going to be always finding characteristics about f. Okay? So what's the purpose? We always want to know about the original function f. Okay? So if given f, they want to know characteristics about f. Given f prime, you want to know things about f. If they give you f double prime, they also want to know things about f. It's always about the original function f. Okay? So if I give you f prime, I don't care about f prime. Alright? I care about stuff about f. Alright? That's what we're going to be doing in this video. So now, what are the 5 things that they will ask you about f? Well, they're going to ask, where is f increasing, decreasing? Where does f have critical points? Where does f have extrema? Where does f have points of inflection? Where does it change concavity? And number 5, where is the f concave up and concave down? Now, these 5 questions are going to be the primary questions they're going to ask you if I give you f and f prime. However, if I give you f double prime graph, if I give you the picture of f double prime, they're only going to really ask question number 4 and question number 5. Where does f have points of inflection, and where is f concave up, concave down? All right. So here we go. Let's look at some examples. In this picture, we're going to assume this graph here is given to us, and this graph is the picture of f. All right. So they want to know where's the f increasing and where's f decreasing. Well, we read from left to right. Okay, so we read from left to right. Now, as I go from left to right, what am I doing right here? I am decreasing. I'm decreasing, 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 and I'm decreasing up to this point. And then what happens after that? Then I start to increase. So we're going to say that it is decreasing. Where's it decreasing? We're going to say from negative infinity all the way to 1. Okay. Now, where is it increasing? It is increasing from 1 to infinity. That's where it's increasing. It's increasing from 1 to infinity. Now, where does f have critical points? Now, critical points are really where you have zero slope or undefined slope. And right here, at that point, we're going to have zero slope. So we have a critical point, a CP, at x equals 1. Now, just because it's a CP doesn't make it an extrema, because all extremas are critical points, but not all critical points are extrema. So what we need to know is, where does f have an extrema? Well, right there at that CP, we're going to say that it has a minimum. And we can say it's an absolute minimum at x equals 1. Now, if I ask for minimum value, you're going to say it has a minimum value of -2. And I'm going to say it touches there at -2. Okay. The next question is, where does f have points of inflection? Where does it change concavity? Well, we can say that in this graph here, it's always concave up. So we're going to say that there is none. There are no points. Now, the next and final question that they're going to ask is, where is it concave up and where is it concave down? Well, concave up, it forms a U-shape. It's a U-shape. Okay? And it's U-shape everywhere from negative infinity all the way to infinity. Where is it concave down? And we're going to say nowhere. There is no place where it's concave down. So those are the 5 questions that they can ask you if I give you the picture of f. Now, what happens if they give you the picture of f prime? All right, so let's go ahead and read this. When given the graph of the derivative, convert it to the sign chart. And I'm going to tell you guys that this right here is the most important part. given f prime, the derivative graph, converted to the sign chart. Now, what do you mean by the sign chart? Well, if we go back to the first derivative test, remember the first derivative test? You take the derivative, set it equal to 0, solve for the critical points, and then you make a sign chart here. And who's on the sign chart? The CP is here and the CP is here. So these are my critical points. Now that I have my critical points, I would take my values here that I chose. Could be any numbers in between these and each interval, but not the CPs. And we plug them into the derivative, and if it was positive, it would be increasing. If it's negative, it's going to be decreasing, and if it's positive, it would be increasing. And then from there, we could sketch the graph of f. Now, in this picture, though, we're given the graph of, let's say right here. This right here is the picture of f prime. And what I want to do, it says here, when the graph is above the x-axis, then f is increasing. When the graph is below the x-axis, it's decreasing. That means that the original function is decreasing. After converting it to the sign chart, you can sketch the picture of f. This will answer the first 3 questions. Okay? So I need for you to understand, this is the picture of f prime. So if I want to make a sign chart, I'm going to make the sign chart right here on the x-axis. Where is this going to be 0? Well, it's going to be 0 right there, Mr. Quintana. You say, someone's going to say, what do you mean it crosses right there, sir? Well, you got to remember that these values here, these here are going to be negative values. And these numbers up here are going to be positive values. So this right here is going to be f prime. This is the numerical value of the y's. Okay? And the y's are f primes. So that means that right here, f prime is negative, positive, 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 positive. All of these are positive because it's above the x-axis. And all of these right here are negative because all of these dots are below the sign, the x-axis. Okay? So what we're going to do is, where it crosses, those are going to be my critical points. So I'm going to say that this guy right here is going to be my CP. Okay, he's going to be my CP. And then right here, because these guys are below, is going to be negative, and all of these are above, so it's going to be positive. So now we're going to say that it's decreasing and it is increasing. So now that I know this, then I know that it's going down and it's going up. So Mr. Quintana, I can answer CPs right there where it crosses. I can answer what's increasing, decreasing, and now I can state extrema. I can answer the first 3 questions if I'm given the picture of f prime. To answer the last 2 questions, you need to understand. They're given f prime. I have to answer f double prime questions. So how do I go from here to here? Well, I need to take the derivative. And the derivative means increasing or decreasing. So I'm going to be looking at what? At the slope of f prime. Because the slope means the derivative of f prime. So if the slope of f prime is negative, then it's going to be concave down. If the slope of f prime is positive, it is concave up. And that's what it says right here. So you can pause the video and you can read this. Okay? So let's look at it. Ready? Now, when I give you this picture, you're going to say, hey sir, I could have sworn we did this picture. Yes, we did. But that was the picture of f. Now I'm going to call this picture the picture of f prime. So I'm going to make my sign chart right here. Oops, I should choose a better color here. Right here. Okay. Right off the bat, I know that this guy is a CP. This guy is a CP. So it asks, where do I have critical points? Well, I have critical points at x equals -2 and x equals 2. All right. So I'm done with one of the questions. The next thing is you look at the sign. You look at above and below. All these dots here, they're above. So that means that they're positive. All these dots here are below the x-axis, so it's going to be negative. All these dots here are above, so it's going to be positive. So now I can say it's increasing here, decreasing here, and increasing here. All right? So where is it increasing? Well, it's increasing from, I can put it here, it's increasing from -infinity all the way to, we agreed that was going to be -2 here, all right? And we're going to say that it's also increasing from 2 to infinity. Okay. And where is it decreasing? It's decreasing from negative 2 to 2. Okay, because it's below the x-axis. Do not read it as if it's the picture of f. Read it as it's the picture of f prime. So what do I do next? The next thing is, where does f have extrema? Well, f has extrema, so now I'm going to sketch it. It's going to be increasing all the way to this point, and then it's going to decrease all the way to this point, and it's going to increase. All right, so it's going to have a relative max at x equals negative 2 and a relative min at x equals 2. And why do you say we have a relative max at x equals negative 2? Because the picture of f prime changes from positive to negative. And why do we say it's a relative min at 2? Because it changes from negative to positive. That's a theorem in calculus, right? So then the next thing is, where does it have points of inflection? So now these two here, these two deal with f double prime, but I'm at f prime, so I have to look at the slope. So what can I say about my slope here? My slope here is negative. It is what? Decreasing. So I can say that f is concave down from negative infinity all the way to 1. Okay? And it is concave up from 1 to infinity. Okay? Alright, now where do I have points of inflection? Well, points of inflection is where it changes concavity. So I can say that I have a point of inflection at x equals 1 because f prime changes from what? From decreasing to increasing. And I have to stop right here, and I have to make sure that everybody understands that the word increasing and the word decreasing, they mean derivative. So the negative derivative of f prime, and increasing means the positive, that my derivative is positive. That's what that word has. It has major strength. Okay, so the word increasing means that it's positive slope. So f prime has positive slope. So f prime, the derivative of f prime is positive. That's what it's saying. Okay. Now the last type of example is if I give you the picture of f double prime. Well, if I give you the picture of f double prime, you can only be asked the last two questions. Where do I have points and where do I have where's the concave up and concave down? So for this slide, all you have to do is convert the f double prime graph into the sign chart. That's it. That's all you have to do. Where it crosses the x-axis are going to be called the points of inflection. Where if they bounce off, then it is not a point of inflection. Now I have to stress that because if it bounces, that means that it's not changing concavity, it's not changing sign. Now if the graph of f prime is above the x-axis, then f is concave up. If the graph of f double prime is below the x-axis, it's concave down. So we're actually doing the sign chart. So we're going to look at the exact same graph, but this graph now, we're going to call this graph f double prime. So now what I'm going to do is I'm going to do my sign chart. There it is. And it crosses there, and it crosses there. Now, if this was f, I would call these guys my zeros. If this was f prime, I would call these guys CPs. If these guys are f double prime, I'm going to call these possible points of inflection. Okay? Now, why are these possible points of inflection? Well, if it bounces off, and some of you might say, sir, I have no idea what you mean by bouncing off. So let me show you. Ready? This right here crosses, so that's a point, and this one bounces off, so that means it's not going to be a point of inflection. It's going to be it doesn't change concavity, so it's not a point. All right. So now let's look at the sign. All of these dots are above the x-axis, so I'm going to say it is positive. All of these dots here are negative, so we're going to, I'm sorry, they're below the x-axis, so it's going to be negative. And all these dots are above the x-axis, so I'm going to say positive. So we're going to say that it is concave up, concave down, concave up. All right. So where do I have poise? I have poise at x equals negative 2 and x equals 2. And where's the concave down? It is concave down from negative 2 to 2, and it is concave up where? From negative infinity all the way to negative 2, and from 2 to infinity. Okay? So what do you need to get out of this? What do you need to get out of this? Well, here's what you need to understand. Okay? If I give you f prime and I ask an f prime question, okay, we're going to use the sign chart. Okay, if I give you f prime and I ask an f double prime question, like a poise or concavity, then we're going to what? We're going to look at its slope. We're going to look at its slope. Okay. Now, if I give you f double prime and I ask you an f double prime question, we're going to look at what? The sign chart. Okay. Now, the other one, if I give you f and I ask an f prime question, we're going to look at what? Look at its slope. And if I give you f and I ask an f double prime question, I'm going to look at its shape. Okay. So that's what you need to understand from this video.